plus 17x squared plus 2x minus 24. All right, they're the same exact graph. I did it right.
What if I didn't write mine in the same order?
That's okay.
They told me it was wrong.
Huh?
Like, it wasn't the same as my graph.
Well, then you did not have the same exact function. The order doesn't matter a ton. Well, you're missing the x to the fourth.
What do you do for the y?
Oh, I got it wrong.
Oh, you have minus x to the fourth. It should be a positive x to the fourth. So the order doesn't matter a ton. I will say, see now they're the same. We do typically write these in descending order, right? So fourth degree, fourth power, third power, second, first, so on and so forth. We traditionally write them in descending order just to make sure it's easy to check to see if we got it right. All right. So from there, first off, any questions about how I multiplied and distributed and got those different, got each of those terms? And I will say, do we need to work on and practice multiplying so we can multiply correctly? Sure. But what's the bigger priority? Understanding how to do it. Because can you just make a simple calculation error? Yes. Okay. How often are you going to have to perfectly multiply binomials for the rest of your life? Not very often. So remember on the rubric, like if you can show me that you understand what you're doing, you can still earn a 4 even if you make a major calculation error. So stop stressing about it. As long as you understand how to distribute, and maybe you just write down a quick note, distribute, and show me that you're attempting to distribute, even if you make an error, you're good to go. If you were to graph it and note, hey, I know I made an error because I graphed it and it's not the same function, you might earn a 4.5 instead of a 4. Right? So like, I need to know that you understand how to do this, not that you can do it perfectly every single time. But you should also be able to check some of these things pretty quickly. So we already have our equation. End behavior. Some people are stressing about the end behavior, like I got to graph it to figure out the end behavior. I mean, can you figure out end behavior from the graph? 100%. But there's only two types of end behaviors. There's even and odd. If it's even, the easiest even function is y equals x squared. Y'all, what's the name of this type of function, or what's the name of this graph?
Parabola.
Parabola. We got to know that's a parabola. What does a parabola look like?
It just touches the line.
It's kind of like a U, and it's concave up. Remember, if it's negative x squared, it's concave down. That's all you got to know for the end behavior. If it's odd, y equals what?
Negative x squared. X cubed.
X cubed. Remember, it needs an odd degree. Okay? What does that function look like?
Goes to the middle.
Squiggly curve that goes through the origin and keeps going up. Remember, that's quadrant 3 into quadrant 1. Remember, if it's y equals negative x cubed, then it's going to look like this. It's a reflection. Okay? So that's all you really have to know to figure out the end behavior. Describe the end behavior. Well, first off, how do we start our end behavior?
As x approaches.
As x approaches what? Okay? Now, if you're talking about x approaching infinity, which end behavior are you referring to? The right-hand end behavior, right? Is x going towards infinity? Yeah, it's got an arrow, it's going to keep going. So make the note, hey, this is my right-hand end behavior. That'll help make sure you don't make any mistakes. As x goes to infinity, what's y doing? It's going up to positive infinity as well. We can tell that because if we look at this arrow right here, it's going up. What's your question, Kyla? Do you need to draw it over here so you can see it more easily? Okay. Just say that. Okay, so remember, as I said just a second ago, even, that's always going to look like a parabola. It's not a parabola. Remember, what type of function are we dealing with?
Polynomial.
I mean, yes, but a quadratic's a polynomial as well. Which polynomial are we dealing with? What degree is it?
4. Degree 4.
So, degree 4, not quintic, quartic. Quintic is 5, quartic is 4, but it's going to look just like a parabola. So there's the even, which remember that can also, if it's negative a, so negative x squared, that'd be concave down. And you can either just picture it, or if you want better points on an understanding check, you do a quick sketch like this. There's my odd. And if it's negative x cubed or a negative odd, it'd look like this. Going from quadrant 2 into quadrant 4. You gotta know those general shapes and end behaviors. Alright, so left-hand end behavior. What am I looking at? What is x approaching now?
Negative.
Negative infinity. It's going to the left. Y is approaching,
Positive.
still positive infinity. Okay? Does anybody know, was anyone able to figure out the y-intercept of the polynomial? Jelani? Can't be falling asleep, dude. We're one day back from Thanksgiving break, gotta stay awake. Come on, y-intercept. Any guesses? Well, how about this? Can anyone tell me what we know about every y-intercept that has ever existed? The x is always 0, right? Look at the standard form. So that would become what? So it's negative 24. Remember, this is just like standard form of a quadratic. What did standard form of a quadratic quickly reveal? We just looked at it. The y-intercept. The standard form always reveals the y-intercept in the form of that constant. So my y-intercept, how would I write the y-intercept? Negative 24. Okay. So a quick sketch of the graph. What features of this graph do we know immediately based on information given? So both the arrows are going the same way, and we already know they're going up. Okay, what else do we know? Has to hit what? 24?
Negative.
Negative 24 on the y-axis. Anything else? Come on, y'all are missing the biggest ones. The easiest ones. Bless you.
It's gonna hit 2.
The root's got to hit 2, and 3, and 4, and negative 1. That's huge because that tells me a lot about what's happening. So I don't know exactly what it looks like, but I know it's got to go through here, and it's probably not going to be a minimum there. It's probably going to keep going through, come back up through the 2, not go up very high because it's got to come back down through the 3, and then back up through the 4. I hit my y-intercept, I hit my x-intercepts, I have the right end behavior. That's enough information. And that's not going to be exact, but let's check. Does it kind of look like the graph that we have in the calculator? Yep. And that's the big thing we have to recognize. Right? We good? Okay. Let's look at the next one. So, zeros to write this polynomial. We're not going to go through all the work on the multiplying because that's going to take forever. So, let's see. Jelani, give me 1, 0 on this graph. We're trying to find the zeros here. Okay. Everyone agree with x equals 1? Cameron says yes. DJ, no?
No.
That was negative 1 or negative 2.
So if you're going to say the 0 is 1, that means right there. Does the function intersect that x-axis there? No. So 2. Okay. That's a 0. Cool. Jada, give me a 0. Negative 1. Gracie, give me a 0. And Cameron, give me a 0.
Negative 2.
Negative what?
2.
2. Lexi, give me another 0.
Huh?
Why are you saying huh?
I don't see anything that other than those 4.
Okay. Y'all agree? No other zeros?
Do we have imaginary?
So here's the thing, can I ever give you imaginary and you know what they are? No. I can give you an equation and you try to find the imaginary, and that's a great thought, Grayson. But yeah, there's no way to know if there's imaginary or not in this one. I will say typically, I know I have imaginary when it looks something like this. What here tells me there's imaginary?
Flattened out the top. Below the extra.
So I have relative extrema without it touching the x-axis. That's probably imaginary somewhere in there, but there's still no way for me to know what they are. Maybe it looks like this even. See how it kind of looks cubic right through here without touching the x-axis? So again, there'd be imaginary zeros in there. But I can't ever expect you to write an equation with imaginary zeros. Alright, so we're not going to worry about multiplying the factors, but what would this equation more than likely be? F of x equals
X minus 2. X minus 3. X minus 1. X plus 2. Or it might be, oh, it's plus 3 and that's positive.
plus 3 here. Okay, what do y'all think? Why not?
Is that the normal thing?
It will be x. It will be an x plus 2 and an x minus 2.
Okay, so we have x minus 2 and x plus 2. This x minus 2 goes with which root? Come on, CD, stay awake.
The positive.
The positive
Okay, that's for the positive 2.
Okay, so make that a minus 3.
So minus 3
A plus 1.
and a plus 1. Now, do we agree? Because remember, it's x minus r1. X minus r2, x minus r3, so it's always the opposite with those x-intercepts. Okay? What is the degree? Okay, so fourth degree, how do we know? So there's 4x, what? Intercepts, or 4 roots, or 4 zeros, right? Notice fourth degree is what you would get a 3 on an understanding check, explaining how you know is how you get those higher scores. Don't forget, we also looked at the relationship between the extrema and the degree. How many extrema do we have? 3, so how many, what degree does it have to be at least? At least 4. Remember, there's always one less extrema, or the maximum number of extrema is one less. So that's a big thing to notice there as well. Do we need to go over in behavior, or we feel comfortable with that? Kylie, go over the in behavior here. Okay. So Kylie, give me the left hand in behavior. Let's start there. How am I going to start that? As what? Okay. Do y'all agree on the left hand in behavior? X is approaching infinity. So remember, Kylie, you want to, if you're going to say left hand in behavior, I kind of threw it off because I started with that, but left hand is going to the left, and so x is going towards negative infinity. Okay, what comes after that? So let's look at what approaches positive infinity? Y approaches. Good. And Grace, you want to do the right hand in behavior?
No, I'm good.
Okay.
I would do it.
All right, go for it, LaShannon.
As x approaches positive infinity.
Okay.
Y is approaching positive infinity.
Okay. Anybody want to push back on that, or do we all agree? KJ agrees.
I got a question.
Yes, ma'am.
Are you looking at the, what are we looking at when we say when they get approaches? Are we looking at the line?
We're looking at the function, the curve, the arrows there.
Oh, okay.
So as x goes towards infinity, y is going towards positive infinity.
Yeah.
Notice I'm looking at the x-axis because that's telling me about the x values for the function, but I'm always looking at the function. I'm not looking at the x-axis for that information. Or the axes completely to give me information. I'm looking at the function. Alright, so hopefully we can identify the y-intercept. What about domain? This is one thing that we do need to know how to do. Domain.
It's the maximum and the minimum, right?
It is the, well, we always start with the minimum, then we go to a maximum. So what is the minimum? Domain is x or y? Okay, it's a negative infinity and infinity. That's all I need to write. Parentheses and a comma. Grace, you notice we're doing domain and range, not maximum. Okay? In range,
It
looks like negative 4.
infinity, positive
That
infinity.
Bracket.
Negative infinity to positive infinity is what LaShannon's saying?
I know, no.
Why not?
It stops.
It stops. What's the lowest y value?
Negative 4.
Notice how we have -4 both here and here.
I should do the infinity.
That needs to be bracket.
And then this -4 needs to be a bracket.
You don't,
So remember, LaShannon, it's the again, it's always based on the function. The lowest y value, it never goes below that point, right? So the lowest y value is -4. The minimum y is -4, but then it's got the arrows and you keep going up to infinity. Okay. We good? All right. Let's have our about 20 minutes to work on the understanding check within our small groups. I'll be coming around seeing if you have any questions to ask. Let's actually skip number 1 for now. Since we've practiced multiplying quite a bit already today. I mean, I know we need more practice with multiplying, but is that a safe way to say we've already done a decent bit of multiplying?